Okay, Assalamualaikum warahmatullahi wabarakatuh. Today, we are from Group 3. We'll present our article summary. The title given to our group is the Biofloc technology, BFT, in indoor tanks, water quality, biofloc composition, and growth and welfare of Nile tilapia, which is Oreochromis niloticus. Okay, first of all, I, Anis, will present about the paper background. Okay, the paper have two authors, which is Ikram Azim and David C. Little. Okay, the paper is published on 24 June 2008 and is carried out at the Tropical Aquarium Laboratory of the Institute of Aquaculture, University of Stirling in the UK. Okay, this slide shows the Scimago journal and ranking of our paper. It has hash index which is 164 and the publisher is Elsevier. Okay, this slide shows the quartile value and the SJR value of the paper. The quartile is Q1 and the SJR value is 1.04. So Q1 show that the paper have the best value, indicating that the paper is good and the valuation of it also is higher. Then the peer review of the paper also become more difficult, so that it makes people can trust and reliable of the paper data. Okay, the table of content is introduction, methodology, result, discussion, recommendation, and lastly reference. Okay, for the introduction, the definition of the Biofloc technology is the retention of waste and its conversion to biofloc as a natural food within the culture system. This experiment takes 12 weeks of the culture period.
So for the objective of this study, they will be divided into two objectives, which is the first is main objective, is to test the suitability of Biofloc technology in light limited indoor tanks for rearing Nile tilapia Oreochromis niloticus. Second, the specific objective will be divided into 5 parts, which is the first is to quantify the contribution of Biofloc to fish growth and production. Second, to evaluate fish welfare in Biofloc technology managed tank, to test the effect of crude protein level in supplemental feed on fish growth and productivity in Biofloc technology tanks, to investigate the effect of level of carbon-nitrogen ratio of feed on proximate and taxonomic composition of Biofloc, and the last, to compare dissolved in organic nitrogen dynamics.
For the first one is for tank facilities and experimental design. The experimental use 250 liter fiberglass indoor tanks, and we have two treatments with 4 replications, which is first treatment is 3 kg of tilapia in Biofloc tank feed with 35% of crude protein, and second one is 3 kg of tilapia in Biofloc tank fed with 24% of crude protein. And we have one control with 2 replications. We use 3 kg of tilapia in clear water fed with 35% of crude protein diet. Okay, the water in the tanks will aerated and agitated using dome diffuser, and the tank also will always cover with lids. Okay, second is fish stocking and tank management. The fish are fed with pelleted feed that developed in the institute itself. Okay, as you can see here, the table show the percentage of raw ingredients and proximate composition, energy content, and the CN ratio of the pelleted feed. Okay, second is fish stocking and tank management. The fish are fed with pelleted feed that develop in the institute itself. Okay, as you can see here, the table show the percentage of raw ingredients and proximate composition, energy content, and the CN ratio of the pelleted feed. Okay. The factor of feeding rates consists of 3 phases. First one, for the first several days, they feed the fish according to the observation of the feeding behavior. Then it will fix at 1.5% of the total stock biomass, and for every 2 weeks, it will alter the feeding rates according to the fish weight. Okay, they will feed the fish daily at 0900 and 1800. Okay, the wheat flour is also added at 60% of feed in the Biofloc tank to maintain optimum CN ratio of the bacteria. If the float level in the water exceeds 500 mg per liter, the float separator is used to settle and remove the float from the tanks. And when the pH is under 6.5, sodium bicarbonate is added to raise the pH to 7.5. Okay, there are 9 water quality parameters taken throughout the experiment, which is water temperature, dissolved oxygen, pH, total alkalinity, total ammonia nitrogen, nitrate and nitrate, nutrient analysis, total suspended solid, biochemical oxygen demand, which is BOD. Okay, for the water temperature, DO and pH, it will take twice for 1 week. For the imaging and identification of microorganisms in the biofloc, first, they will collect the water sample and dilute with the pre-filter water. Then it will stain with fluorescence 4,6-diamidino 2,2-phenylindole, and it will observe it under confocal microscope. After get the image, they will photograph at 10 magnification. For the taxonomy of other organisms, well-mixed water samples are collected in 30 ml bottle. Then, add several drops of Lugol iodine to kill the organism. Place 1 ml of counting chamber and left for several minutes to allow the organism to be settled. Then, select 10 randomly to identify and count using magnification of 20 to 40 of binocular microscope, which is X. So, the total number of organisms per ml in the water, the value that we get before this, which is X, need to be multiplied by 100. This step repeated for 3 times in each sample for each tank. For the fourth one is the determination of biochemical composition of biofloc. Okay, concentrated floc samples are collected for proximate analysis. Okay, proximate analysis we have for ash content, crude protein, lipid content, energy content, CN ratio, and fatty acid. Each of the proximate analysis have their own method to analyze it. For the fifth one is the determination of fish welfare indicator. Fish welfare include the length and the weight of the fish, skin or fin damage, gills, for the histology and examine for the parasite. Fourth is the skin mucus. 5 if the blood sample. The blood sample is taken for the hematocrit and the concentration of the plasma cortisol. As for the last one is the statistic analysis. They use two-way repeated ANOVA to analyze water quality parameters and one-way ANOVA to analyze fish yield, blood parameters, biochemical composition in flock, biochemical composition of fish, and this analysis is tested with Tukey multi-comparison test at 5% significance level.
So for the result, basically there are 5 measurements that are taken by the researcher in this experiment. The first is water quality, second, nutritional quality of biofloc as fish food, the third, taxonomic composition of biofloc, the fourth, fish yield parameter, and the last, fish welfare indicators. So for the first parameter measure is water quality. The average water temperature recorded for all 3 treatments were 28 degrees Celsius with range of 26 to 30 degrees Celsius. Average DO concentration recorded was 6 mg per liter with range of 3 to 7.5 mg per liter, and average pH recorded was 6.7 with range of 5 to 8.5. Total alkalinity was very stable in the control tank, which were 18 to 27 mg per liter, but it fluctuated very much in the tanks with Biofloc, which 8 to 250 mg per liter. The average total suspended solid level TSS were 60 mg per liter in the control, 597 mg per liter in BFT 35 and 560 mg per liter for BFT 24. Efforts were made to control TSS at 500 mg per liter using floc separator, but the levels is out of control when the sampling recorded that reading for both reached 1000 mg per liter for both treatment. So for the second part of parameter measure is nutritional quality of biofloc as fish food. Basically, there were no significant difference in any nutritional parameters between 35% and 34% crude protein feed treatments. The biofloc quality in terms of fish nutrition containing 38% protein, 3% lipid, 6% fiber, 12% ash, and 19 kJ per gram energy. So as we can see from this slide, it show the table where the composition of 35% crude protein feed and 24% crude protein feed are not likely different, where all the nutritional composition are quite similar. Biofloc then further analyzed to see whether it contains essential fatty acid in the lipid for the post-treatment. The result again shown that there are 27 to 28% of polyunsaturated, which 35% crude protein feed treatment recorded higher in N3 polyunsaturated fatty acid, and 24% crude protein feed treatment recorded higher in N6 polyunsaturated fatty acid. The other data again shown that 28 to 29% monounsaturated, which 24% crude protein feed treatment is higher level compared to 35% crude protein feed treatment. 30 to 35% saturated fatty acids, which 35% crude protein feed dominate compared to 24% crude protein feed treatment, and 10 to 12% of unknown peaks, which 24% crude protein recorded higher level compared to 35% crude protein feed treatment. The third part measured in this experiment is the taxonomic composition of biofloc. The floc most likely similar in shape but varied in size ranging, which was 50 to 200 micrometers. 3 groups of organisms were identified, dominated by protozoa in each treatment, followed by Rotifera and Oligochaeta. Protozoan-dominated genera consists of 3 different species, while Rotifera-dominated genera consists of 4 different species. Only Oligochaeta-dominated genera consists of 1 type of species. The total number of organisms was significantly higher in the low protein fat tanks, followed by the high protein fat tanks and control. So, for the fourth part measured in this experiment is fish yield parameters. There is significant difference in weight gain by fish when Biofloc applied in the experiment and without application of Biofloc. As we can see from the table shown in the slide, initial individual weight shown that there is no significant difference between all treatments, but the final individual weight shown that there is significant difference between treatments. Survival rate for all treatments shown that there is no deaths recorded. For individual weight gain, treatment with Biofloc applied shown that they recorded higher weight gain compared to the treatment without application of Biofloc. For the FCR or feed conversion ratio, the treatment without Biofloc application recorded higher ratio compared to treatment with application of Biofloc. The last parameter measured in this experiment is fish welfare indicators. Visual and microscopic observation of skin, fin, and gill indicate no physical damage in any fish in all treatments and control. However, by using histology method, fish gill examined in treatment BFT 24 found that 4 were perfectly normal in the treatment. Some primary filaments of the remaining 4 gills and had minor distal extremity thickening, and 1 gill had couple of very minor nodular focal thickening lower down onto filaments. The fish gill examined in treatment BFT 35 used by histology found that 6 gills looked perfectly normal. 1 had thickening of distal extremities of some primary filaments, and the remaining gill display telangiectasis in 5 adjacent filaments near distal extremities. In the control treatment, fish gill also examined by histology found that 4 were perfectly normal, 1 with telangiectasis, and the remaining had minor distal extremity thickenings.
Okay, for the discussion, firstly about the water quality. The result of the water quality indicate that the Biofloc system has lost its buffering capacity. So, it required frequent additions of sodium bicarbonate into the tank. There are also high rates of nitrification, which is indicated by the constant nitrate accumulate coupled with ammonia immobilization into the bacteria. So the Biofloc system must always have continuously vigorous aerations to ensure that the oxygens in the tanks are not limited. The qualitative change in flux also occur because sometimes the flux will settle down at the bottom of the separator, and sometimes it will float on the surface. And the optimum float levels in terms of total suspended solid is in relation to the fish stocking density needs further investigation. It is because if the higher fish stocking density, the total suspended solid level also become higher. The biochemical oxygen demands level correspond to the total suspended solid level in the tank. There are significant time effect and treatment time interaction, which is indicate that the concentration in different treatments behave differently over the time. In the experiment, there are 3 principal pathways to remove the hazardous nitrogen species in aquaculture. Firstly is the photoautotroph removal by the algae. Secondly, the immobilizations by heterotrophic bacteria as proteinaceous microbial biomass. And lastly, chemoautotrophic oxidation to nitrate by nitrifying bacteria. These pathways are important to remove the hazardous nitrogen species. Next, the system was dominated by nitrifying bacteria, aside from the heterotrophic bacteria. CHO requirement that needed to minimize total ammonia nitrogen in the tank need furthermore study. Okay, second discussion is about nutritional quality of biofloc as food source. Okay. Second discussion is about nutritional quality of biofloc as food source. In the experiment, there are no significant difference in any nutritional parameter between 35% and 24% of crude protein feed treatment, which is indicate that the biofloc quality was independent with the feed quality. They are suggested that 25 to 30% of crude protein and 6 to 8% of crude lipid in tilapia diets are for the larger. Oh, okay. Secondly, the discussion is about nutritional quality of biofloc as food source. In the experiment, the biofloc's quality was independent with the feed quality because there are no significant difference in any nutritional parameters between 35% and 24% of crude protein feed treatment. They are also suggested for the larger tilapia fish, 25% to 30% of crude proteins and 6 to 8% of crude lipids are suitable for them. In the study case also reported that the lipid in tilapia are sufficient to meet minimal requirement of juvenile hybrid tilapia, which is cross of Oreochromis niloticus and Oreochromis aureus, but only 12% are needed for maximum growth. The fiber contents that exceed 8 to 12% and ash content 12% are not desirable in diet of fish because the increase of the ash content in the diet can decrease the quality of usable nutrient in the diet. Next, the biofloc quality in terms of fish nutrient was suitable for tilapia except of its low crude lipid level. So, a better quality biofloc was reported in similar system but without a fish, which indicate that in situ floc utilization by fish could have effect on biochemical composition of the flocs. Third discussion is about taxonomic composition of bioflocs. The blue channel was dominated by cluster of bacteria nuclei. There are also trace amount of mucopolysaccharides typically secreted by the bacteria, which is green channel. In the result, we also know that the floc more or less similar in shape but vary in size which is from 50 to 200 micrometer. It also states that there are three groups of organisms were identified in the biofloc, which is Protozoa, Rotifer, and Oligoceta. And each of the groups, they have their own genre. The organism is higher in the low protein feed tank, which is 24%, of crude protein and low in control tank. Maybe because of the 24% of crude protein is suitable for the organism to grow. So in the natural system, coupling between bacteria and heterotrophic nanoflagellates was such that about 10 to 70% of the water column was daily cleared of the bacteria. Next for discussion is the fish yield parameters. Each individual weight at harvest was 9 to 10% higher in BFT rather than in the control tank. The BFT treatments contribute on 44 to 46% individual weight gain and net fish production because of the utilization of the biofloc as food source for the bacteria. Mostly of the tilapia, such as Mozambique tilapia, can utilize in situ produce food particles, including the suspended bacteria, by using stable nitrogen isotope labeling technique. There are also no significant difference in fish growth or production between 35% and 24% of crude protein feed tank under BFT. The FCR value significantly higher in control tank rather than the BFT treatment. The poor FCR and level of productions was well below commercially viable level. The reason attributed to poor fish growth and the production. Firstly, maybe because of the increased turbidity due to the biofloc reduced visibility and hence artificial feed intake. There are critical issues to maintain the optimum level floc of in the tank because it is not easy to maintain the total suspended solid level in the tank, although by using the floc separator. Next, the reason because of the water quality parameter were not stable. There are high fluctuation of pH and alkalinity, and also the concentration of inorganic nitrogen species in the tank is higher, which is might have chronic effect on the fish health. Lastly, maybe some of the level of the fish reproduction occur in the tanks. Mostly fish seed did not survive until the end of the experiments due to the advanced water quality on some occasions or repeat agitation of the water or maybe of because of the cannibalism. Lastly, for discussion is fish welfare indicator. Through the observation of skin, fin and gills indicate that there are no physical damage in any fish. Mostly the fish gills are perfectly good in treatment of 24% and 35% of crude protein feed treatment and also in the control tank. Only some have minor distal extremity thickening, couple minor nodular focal thickening, and the remaining have had telangiectasis. They are show that high level of suspended solid are related to this poor fish welfare, indicated by the poor growth of the fish, the fusions of gill lamellae, and a susceptibility to bacterial or parasite infections. So there are no significant evidence that show potential gill damage due to the presence of biofloc, as both treatment with or without biofloc had minor abnormalities. There are also conducted experiments between PFT and RAS treatment. After 1 hour stress, The concentration increased by 8 times in the treatment of BFT 35% and by 5 times in the control RAS 35%. This difference may be due to the increase of initial load and challenge from the bacteria entering the fish of the tagging site in the Biofloc treatment. There are also no significant difference in any fish nutritional parameter among the tank under the Biofloc treatment and the control tank.
From this article, we can conclude that Biofloc clearly contribute to the growth and production of fish in light-limited indoor systems. Second, the nutritional quality of Biofloc was appropriate at least for herbivore and omnivore fish species. Then, the Biofloc technology seems not appropriate to those species that do not graze on Biofloc directly. And the last one, the preliminary study indicate that microbioflocs generated in biofactors using fish waste and offered as supplemental feed improve shrimp growth. That's all from us. Thank you. Next, we move to the recommendation. There are several recommendations that we can apply to increase our Biofloc technology. First, the low CN ratio can be augmented by adding supplemental material with high CN ratio. Second, the input CN ratio can be increased by reducing feed protein content. The third one, suggesting the preference of heterotrophic community rather than nitrophilic bacteria in the BFT system. Next, carbohydrate material should be convenient and low cost. Then, use simple carbohydrates such as sugar or starch that have quick effect. Last, use of commercial bacteria consortia help to stabilize the heterotrophic community.
For the reference, first is AOAC 1990 Official Methods of Analysis in Horwitz W. Edition Association of Official Analytical Chemists, AOAC International, OMA, Washington, D.C. Second, APHA 1998 Standard Methods for Examination of the Water and Wastewater, 22nd edition, American Public Health Association, Washington, D.C. Third, Y. Evney 2006 Biofilter, The Need of a New Comprehensive Approach, Aquacultural Engineering 34, page 172 to 178. Fourth, Y. Evney 2007, Feeding with Microbioflocs by Tilapia in Minimal Discharge Biofloc Technology Ponds, Aquaculture 264, page 140 to 147. Fifth, M.E. Azim and D.C. Later, 2006, Intensifying Aquaculture Production Through New Approach to Manipulating Natural Food, CAB Review, Perspective in Agriculture, Veterinary Science, Nutrition and Natural Resource 1, number 062, 23 page. Lastly, M.E. Azim, M.C.J. Verdigum, I. Martin, A.A. Van Dam, and M.C.M. Beveridge, 2003. Ingestion and utilization of periphyton growth on artificial substrate by Nile tilapia, Oreochromis niloticus, Aquaculture Research 34, page 85 to 92.